Alright, hello ladies and gentlemen, welcome back. This is the second video, so if you haven't seen the first one, it might be worth going and seeing the first one because I'm going to refer to that. This is part 2. In the last video we looked at completing the square, where if we have something that looks like this, which expands out to be this, remember, because square just means times by itself, then we could find a general rule to solve it. And we can solve it actually for any number that we decide to put in for this one in here. So it could be 1 billion, but we know the rule to solve it and to get all the way to the end. But the cool thing is that we also know how to go back the other way. So if we know how to, if we know the answer and we can solve, we can factorize it to get back to this original problem. We're going to try the same thing, but for this style of question down here. So I'm going to raise that and have a look, see if you can notice what all of these have in common. It should be fairly straightforward. They're just two brackets, two sets of brackets. Inside they've got one with a plus next to it and one with a minus next to it. And so they each have the same thing, but that number's been changed out. So we've got 1, 2, and 3. I'm going to try expanding this first one and let's see what happens. We're going to use FOIL again. So the first gives us x squared, the outside gives us negative 1x, the inside gives us positive 1x, and then the last terms give us what's 1 times minus 1. Well, that happens to be minus 1. Now, what you'll notice is if we've got a minus 1x and a plus 1x, they actually cancel each other out. So I'm literally going to cancel them out and we're left with x squared take 1. Interesting. Let's try that with this one. We've got x squared, outside is negative 2x, our inside is 2x, and our last 2 times minus 2 is minus 4. Oh, what do you know? These two inside ones cancel out. So we're left with x squared take 4. You might be able to predict this next one, but we're going to do it anyway, just for the sake of continuity. We've got x squared take 3x plus 3x take 9. These cancel out in the middle. We're left with x squared take 9. Cool. Now, you might already have been able to figure out the pattern, but I'm going to do this mathematically, and we're going to prove it using a general term. So we're going to do this, where we're going to use any number, preferably any integer, and we're going to see what happens if we just use n and see what comes out at the end. X squared take nx plus nx take n squared. These two still cancel each other out because you've got a plus nx and a minus nx, a negative nx, sorry. X squared take n squared. Cool. So what we've just found is a general rule saying that whatever value that we put inside in this form of brackets, where we've got the first one is x plus the number, and the second one is x take away the number. However we expand that out, we are gonna get x squared take n squared. So you might notice this first one was 1 squared. This second one was the 2 squared, gives us 4. And this third one, the 3 squared, gives us 9. This last one, n squared, could be any number you want, gives us n squared at the end. Now, that is not the full picture. Like last time, our job in algebra is to be able to factorize to expand and to factorize. So to go from this question to the answer, and also be able to sometimes recognize how we can go from the answer back to the question. So let's go down and answer a few questions. If I want you to factorize these two, and I want you to put them back in their bracket form. Let's do a third one as well. You might be able to figure these out pretty quickly. Might take you a little while, but there's no rush. Can you pause the video here to answer them yourself, and then we'll do it together. So pause it here. All right, welcome back. So we expanded out. We're going to have these brackets, just like we did above up here, where we started off with the brackets. I'm going to write them in for all of these, because that's our goal, remember, at the end. We're wanting to factorize them back into their factors. So all of them had an x in the front. And remember, all of them had a plus and a minus. What is 64 a square of? What can you square to get 64? And the answer happens to be 8 squared is 64. So this is the factorized form. All right, what about with 81? You might know that that's 9. And what about with 16? You might know that that's 4. So if you got these as your answer, give yourself a big fat tick. Well done. You now know how to factorize using the difference of two squares. All right, and that's the end of the video. Like, share, and subscribe. Bye.